So we're going to solve number 32, and we're going to start with a conical tank. And the tank has a radius of 4 meters and a height of 5 meters. And this is draining into a cylindrical tank. The cylindrical tank also has a radius of 4 meters and a height of 5 meters. What we're trying to figure out is if the water level in the conical tank drops at a rate of 0.05 meters in a minute, what rate does the water level in the cylindrical tank rise when the water level in the conical tank is at 3 meters and 1 meter. So we're going to start off by finding the right equations to solve this. And for our cone is the volume equals 1/3 pi r squared times height, and our cylinder's volume equals pi r squared to height. Now with our cone, we can express our radius with respect to our height, because using the similar right triangles. So our radius will equal 4/5 height. Then we're going to replace that in this equation. So the volume for this one is going to equal 1/3 pi 4/5 height squared times our height, which can be simplified into 16/75 pi height cubed. The next step is to solve for the derivatives of each of these equations. So our derivative of our volume with respect to time for our cone is going to be 3 times 16/75 pi height cubed times the derivative of our height with respect to time. This can be simplified into 16/25 times pi times height cubed squared times the derivative of height with respect to time, and the derivative of our volume of our cylinder is going to be 16 pi times the derivative of height with respect to time. The next step is to take our 3 meters and our 1 meter from the problem and plug them into the derivative of our cone. So we take the derivative with respect to time, 16/25 and for our height, we're going to plug it in at 3 meters and 1 meter. And we were given in the original equation the rate of change for our height at 0.5 meters per minute. And once we do the math and plug both of those in, at 3 meters, it's going to equal 2.88 pi, and at 1 meter, it's going to equal 0.32 times pi. Now with these, since we're solving for the height with respect to time in our cylinder, we're going to take derivative of our volume and we're going to take each of these points and plug them in for our volume and then solve for the derivative of height with respect to time. We plug each one of those in, and the derivative of height with respect to time at 3 meters is going to equal 0.18 meters per minute, and the derivative of height with respect to time at 1 meter is going to equal 0.02 meters per minute. And that's how we solve that.